Welcome to the fifth video of this series. In this session, we'll use the new spline nodes in Designer to create a shear fabric for the dress model we created earlier with Clo3D. Let's start by creating a new substance graph. And let's select metallic roughness, set the name and the resolution to 4K with the 16-bit output format. Let's hit OK and move the outputs out of the way. Go to the package and link to it the dress mesh. Locate the dress geometry and load it. Designer then asks if we want to use the mesh as a UDIM mesh. That's a mesh with multiple UV tiles. Say yes to that. After dragging the mesh into the 3D viewport for a preview, let's right-click on the mesh name in the Resources folder and select Bake Model Information. For this example too, we need a UV mask. To get that, let's set the size to 1K and choose PNG as the format. As we will use the mask only for previewing, we don't need it to be very high resolution. Add a Convert UV to SVG Baker. Define the output folder. Select all UV tiles. Set the color mode to uniform and start the render. Now that the map is baked, we can use it in our graph. Although all 4 tiles have been baked, viewing them simultaneously in the 3D viewport is not possible. We'll need to preview one at a time by connecting the UV mask to the base color output. Let's also add an Edge Detect node to it and connect the Edge Detect to the base color output. After hooking up a gradient map to convert it to a color node, right-click on the graph to assign it. Then, find the material of the dress and select the tile number for previewing it in the 3D view using the pop-up selector at the top of the screen. Currently, Designer only allows previewing one tile at a time, but that won't be a problem here. Hold Shift and Ctrl and click and drag around the dress in the 3D view to reposition the light and review the results. Let's go ahead and save here by right-clicking on the package and selecting Save As. Let's start out our material by using a spline polyquadratic node, one of the new vector tools in Substance Designer. With this one, we can manipulate up to 10 spline points and create a smooth squiggly curve. The exact shape is entirely up to you. Let's aim for something that will work when we give thickness to the curves. It will all make sense soon. After experimenting with the shape, plug this into a spline mapper color node. Make sure that all of the outputs of the spline node connect to the first 4 inputs of the spline mapper. In the spline mapper, take the segments amount up to 32 for smoother curves. By changing the thickness mode, we can alter the thickness of individual spline points and view the final result immediately. Remember, the point thickness parameter is in the spline node. Again, don't worry too much about the exact shape right now, as we'll get back to it later. Play with the thickness multiplier in the mapper to adjust the overall thickness of the curves. Next, plug in a uniform color into the spline mapper to give a specific color to your curve. Duplicate these 3 nodes and change the second uniform color to something distinct. Let's now blend the ID outputs of the spline mappers in Add mode. As you can probably tell, we've started with simple shapes and will gradually build them up to an increasingly complex design. By utilizing the Blend node, we'll create 3 color curves and 3 masks, combining them with blends. Let's invert this first blend, and then blend the 2 spline mappers with the inverted blend in the opacity input. We can now go back to our splines and work on the design. The third element we'll introduce to our design is a spline circle. Let's make this one blue and treat it the same way as our previous splines. In this spline mapper, increase the segments amount to 32 for a smoother circle. After converting the final blend to grayscale, use a histogram scan to convert the design into a black and white mask by dragging its position parameter up to 1. Then, blend the result with the circle in subtract mode to subtract the circle from the rest of the design. This chain of grayscale nodes, after the last blend, will help create a mask for the next blend that we'll make. Then invert the result and use it in the opacity channel of yet another blend to combine the circle with the rest of the design. Let's convert this last blend to grayscale. Next, connect it to a gradient dynamic node. This process will enable us to select the palettes of any design we have previously made and apply them to the new design. For the next step, you can load any packages you've previously created for your jacket and drag them into the graph to use their outputs. We're doing this so that the colors of the dress will complement the colors of the jacket. Make sure the multiple connection option is off. Then, link the jacket material's base color into the gradient input to use its palette in the new design. We're only using the first 4 colors here. We still have our SVG UV mask ready here, connected to an edge detect and then a gradient map. Plug it into a blend node alongside the new dynamic gradient node and set the blending node to multiply. We're doing this to combine our splines design with the edge of the dress's UV map. Connect it to the base color output for a preview. Add an invert node between the edge detect and the gradient map. And set the blending mode of the blend node to screen. Let's now reduce the saturation significantly to create more subdued dress colors that complement the jacket's tones. Take the grayscale conversion of the splines, plug it into an edge detect, and blend it with the edge detect of the switch UV mask. This connection integrates the 2 elements more closely. After setting the blend mode to multiply, make some more room by reorganizing the graph, and then insert the blend between the edge detect and the invert grayscale. This results in better integration between the 2 elements. Make some adjustments, playing with the options of the edge detect to get the result you like. Then insert a second edge detect node to further integrate the 2 elements. Invert the edge detect and then convert it with a gradient map. You can also experiment with the edge roundness of the edge detect node. This has kind of an Art Deco feel to it. The whole idea here is to start simple and gradually get to a complex and intricate design. If you now test the design with different UV tiles, you will see that the baked SVG mask consistently outlines the panels of the dress. Since everything is live and editable, you can modify the original curves and all effects and processing will update in real time. For example, you can adjust the circle's radius to fit within the skirt panel, or move it around by connecting it to a Transformation 2D node. If you add a transform node here, make sure to also create a new mask to replace the ID of the spline mapper. To do this, you first need to convert the transform node to grayscale. Then make it black and white with a histogram scan, turning the position up to 1, and then connecting the result to the blend the circle's ID was connected to previously. Now you can freely move the circle around in context. If you have made any additional designs for the jacket or for any other purpose, feel free to load them now. We can use their color palettes. To be able to switch between them, we'll plug them into a multi-switch node. Make sure that any external package you link here is packaged with your material if you plan to distribute it, so that anyone can use the material without problems. Connect the multi-switch to the gradient dynamic that leads to the color output. By previewing the input selection, you can see how everything adapts to match the palettes from previously made graphs. Now is probably a good time to create frames around our sections and give them distinct names so that we can read the graph more easily. We can also build an input for reading UV maps in Painter. Create a new attribute inside it and set it to Mesh UV Mask. Set the identifier to Mesh _UV_mask and the label to UV Mask. Then create a switch grayscale node and connect the SVG and the UV mask to it. This will allow you to switch from the baked UV mask of the current mesh to any mesh's UV mask in Painter. I've added a grayscale conversion node here, but you don't really need that as the UV mask has both a grayscale and a color mode. You can switch between the two inputs to test the switch node. Expose the switch parameter of the switch node by clicking on the icon next to the parameter title and choosing Expose as new graph input. Give it a name, in this case UV mask, and input two labels for the true and false states: Baked UV Mask Designer and Dynamic UV Mask Painter, or something like that. You can test the exposed parameter by clicking on the graph's background and going in the Preview tab. As a side note, you can export the baked SVG UV mask as a bitmap, link it or import it again, and drag it onto the input node in the UV mask input node to preview it. This eliminates the need for a switch if you don't want to have a dynamic, updatable UV mask in Painter. Before moving on to the next step, let's add some more frames and reorganize our graph. Let's now start working on our fabric. We'll create a weave generator node to introduce texture and detail to the dress's fabric. To get a sheer, semi-transparent appearance, we need to increase the gap between the threads. Let's set the gap X and Y to 0.8 and tile the weave with the Tile Sampler node. To use the weave with the Tile Sampler, you'll have to set the Tile Sampler's pattern parameter to pattern input. Also set the scale to 1 and the X and Y amount to 100. The current parent input filtering option here creates some problems with the connections between the weave pattern pieces, so change it to nearest. We could have just used a Tile Sampler here to control the scale of the weave. But in this case, I will also add a Transformation 2D node. Using various nodes to get to the same destination can give us slightly different results, as well as more parameter options to use and expose. So we're keeping our options open for the moment here. Next, take this into the normal map. A Sobel normal is sometimes preferable for materials like fabrics, as it filters more than the standard normal, giving you a more gentle effect. You can notice the difference here. The usual normal appears a bit harsh. Let's go with the Sobel for this one. Select the weave nodes, frame them, and label this section normal. Now link the edge detect from the color design to the roughness output. This will create a contrast where white parts are shiny and black parts are matte. All white sections here are completely matte and black parts are fully glossy. Repeat a similar process for the metallic sections, but in this case invert the map. This way, we are utilizing full metalness on the outlines and no metalness at all on the fills. Next up, connect the inverse of the edge detect to the height output to raise the outlines. Moving to the material display, increase the tessellation factor to refine the displacement, and increase the height scale. This adds a little more height to the metallic parts to make them a little more prominent. Now that we've set the displacement options, let's adjust the height parameter. Let's adjust the black levels up to dark grays and white levels down to light grays, compressing the image to get a more subtle effect. Following that, connect an HBAO node to the ambient occlusion output. This will make the details pop out a little more. Adjust the height of the occlusion to extract more detail from the fabric without making it too dark. Let's also make an opacity output as we're dealing with a semi-transparent fabric. For this to work, we have to add an item to the usage attribute and set its use to opacity. The identifier will be opacity, all lowercase, and the label can be anything, but let's also call it opacity here. Let's now make an opacity mask to plug into our opacity output. By connecting the weave to a histogram scan and using a blend, we will create a mix of the weave with the dress print. This ensures that the metallic outlines remain fully opaque. I applied the material to a cube to visualize it more easily. Playing around with the 2D transform node allows us to test how well the transparency works by multiplying and dividing the weave by 2. Next, let's expose some parameters so that we can later use them in Painter or in other programs through the Substance plugin. Let's name the multi-switch for the palettes, and adjust the sliders' default, minimum, and maximum values. Let's test it in the Preview tab of the parameters. It seems to be working fine. Let's also expose the edge width and roundness of the final edge detect, its invert option, the saturation of the HSL node after the final blend, and the intensity of the normal. Let's also add a levels node before the metallic output, exposing its level out high parameter and calling it metallic, as this is the parameter that will specify the amount of metalness. We also have a levels node leading to the height output. And in this one, let's expose the level out low parameter and call it height base, as well as the level out high parameter and call it height. They will be controlling the midpoint and intensity of the height. Additionally, let's expose the height depth parameter of the HBAO node so that we can control the amount of ambient occlusion. I eventually decided to get rid of the Transformation 2D node after the tile sampler and to just control the scale of the weave with the tile sampler. To this end, I'm exposing the X and Y amount parameters in the tile sampler. Let's also expose the weave and gap distance in the weave generator. Alright, we've now finished our graph and are ready to optimize it. For this, consider the balance between quality and processing footprint for each node. First off, change all uniform color nodes to absolute output size and their width and height to 16 pixels. Then change all your graphics to absolute and as low a width and height as possible without losing significant quality. If you see that the quality deteriorates too much and you get unwanted artifacts or mismatches, raise the resolution back up until they're resolved. Let's also make some adjustments to the weave generator node and the tile sampler. The weave will be tiled many times over the surface of the dress, so its resolution can be quite low. Make sure to set the tile sampler and all other nodes that apply to the full surface rather than just to individual tiles to parent, so that they adhere to the resolution of the full document or the parent material. Let's finish off by grouping the parameters under categories that make sense when using the material later. With these steps completed, we have crafted a unique design for a Clo garment using splines. Thanks for watching. In the next part, we'll take this material into Painter, apply it to the dress, experiment with its parameters, and export maps to use in Unreal.